Good morning, I'm Jim Armstrong. I'm the department head for Advanced Industrial Control Center. We're going to go through a distillation column today. It's actually a glass distillation column, and we're going to go through the lab for it. The column is actually behind me here, so great if we can get a shot of that column. It starts down at the bottom end in here, and we progressively work our way up through the trays from top to bottom, and it goes a long ways up there, and finally the overheads condenser sitting at the top. This is what is called tray 1, tray 2, tray 3, tray 4, 5, 6, 7, 8, and 9. Or 9 is actually in the bottoms here. There's a reboiler, which is on the side. You're going to see this all start up a little bit later. It's drawing liquid from here, and by thermosiphon it'll be injecting it back into the column itself. We're going to apply steam. It's going to come in on this red hose here, and it goes through the tubes and goes out as condensate heading out of this bottom hose, and that goes around through that blue thing down there, which is a trap, a steam trap, and then the condensate gets dumped to sewer. Okay, so my little descriptor here talks about this normal propyl alcohol, which is 1-propanol, and isopropyl alcohol, which is 2-propanol, and the distillation column. So if we take a look at 1-propanol, or normal propyl alcohol, you'll see that the formula up here reads C3H8, and it's got a boiling point of 97 degrees C. This is the structure, okay, the structure of it, organic structure of it. And you can see in here, it's kind of it's not a straight line, but the molecules are lining up more or less straight. And this is used for a variety of different possible applications. The original stuff of this actually came out of the fermentation of alcohol and distillation of alcohol, where you get fusel oils as a cutoff, and this propanol was extracted out of those fusel oils. If you want more information, go to Wikipedia and it'll tell you everything you need to know. The isopropyl alcohol is indicated here as a structural isomer, and you can see that the pattern is different, okay? But the formula is exactly the same. It's C3H8. However, it is a lower boiling point. The boiling point is sitting at 82.5 degrees C. And so in this IPA NPA mixture that's sitting in our glass distillation column, this is the more volatile component, or the most volatile component. That's not most valuable component, it's the most volatile component. And so we're going to use our distillation column to separate these. In fact, in the bottom of the column we've got about 25 US gallons of liquid in there, and it's made up of 20 gallons of NPA, the normal propyl alcohol, and 5 gallons of the isopropyl alcohol. Then if I look at the next page in my notes, edit that. This is a McCabe-Thiele theoretical plate. And this is a method of calculating how many trays are required to perform the distillation that we want to perform. And the drawing here is a plot called a liquid vapor equilibrium curve, and we look at the mole fraction of the liquefied vapor and on one side, and we're looking at it at the liquid phase and the vapor phase, the two phases compared together, a mole fraction percents of the particular materials we're trying to separate. Down at the bottom, you can see a distillation column. We've got a bottom section. Up at the top, we get our distillate coming off. So I've marked those in blue and in red. And when we're feeding into the distillation column, we will feed a mixture in at a point in the tower where that component mixture is actually found. So in this case, it was going to tray 3. So that's marked in there as feed tray. So McCabe-Thiele tells us how many trays. Everything from the feed tray up is the rectifying section, which is kind of cleaning things up. Everything from the feed tray down to the bottoms is the stripping section, where it's actually kind of ripping the stuff apart. The other thing I wanted to point out is that this drawing is very important to us on the control side of things. And down on my bottom lines here, the significant information that we get from McCabe Thiel are, first of all, the composition of the top and bottoms products, because you can't have pure NPA and you can't have pure IPA. You're going to get somewhere in between them. Composition of the quality of the feed that's going in, we need to know that. Then we need to know the reflux ratio. That is, how much reflux are we going to put back into the column compared to the amount or the product that's coming out of the column. And the other thing it's going to tell us is overhead's condenser duty. Now, this is the condenser that takes the vapors coming out of the top of the tower and condenses them. And so you've got a lot of energy because you're taking out the latent heat of evaporation out of the actual liquid itself, or vapor, I'm sorry, to bring that into a liquid phase. And lastly, we need to know how much steam do we need to apply, and we call that the reboiler duty. So we need to size flow meters and control valves and other things to provide the amount of heat that we need to complete this distillation. So now if I go to the next page, you'll see here, this is an equilibrium curve for McCabe Thiel theoretical plate calculation, which was done by Alan Wilkes a number of years ago. And when he did the calculation, he came out and it actually shows that there's 9 trays in here. Now, from the engineering side, when they actually build these things, or not build them, but when they design them, tray number 1 is at the top, and that's where the most volatile component is, and they work their way down to tray number 9. In the industrial version, which we have one over in the industrial instrumentation lab, the trays are actually numbered from the bottom upwards. And it's not really a mistake, it's just how in industry they do it. And ours at tray 1, we're actually running 90% ethylene glycol and 10% water, and we've got 1% ethylene glycol and 99% water at the top. In the case of the NPA IPA, we're running down at the bottom at about a 20% mixture of NPA, IPA and the NPA, and much, much higher. But we never get the pure IPA at the top and pure NPA down at the bottom. Okay, then this is just some quick pictures of the column so that when we do see things happening on the video, you'll have a better perspective of what's going on. As we heat it up, when we apply steam into this reboiler, there's a red hose in here, and you'll see on the video, you'll see this actually, the steam going around inside the tubes and coming out as condensate. When we heat it up, it expands in volume, and as a result fills up and spills over into the actual bottom section of the distillation column. The product then is drawn out and circulates around and eventually starts to thermal siphon, and this is how we actually heat the liquid up. The bottoms tray is L9 is actually what's in the bottom, in the bottoms of the column. And then we go up, the very first tray we run into is, from engineering standards, liquid 8 will come on that because they consider that to be tray number 8. And then we progressively can work our way up the tower. The product coming out of the bottoms would actually come off of a line down where my pen is pointing, right down at the very bottom. It's off the end of the picture. And we'll be getting our sample from there, okay, for our bottoms liquid. Looking a little further up the column, you can see one of the bubble caps in here, and there's another one there and another one up there. And so we're going to be taking our L7 in here, and we'll be taking our L5 off of here, and we'll be taking L4 is actually off the backside, so that's why there's no hose hanging off of there. And they'll flip-flop back and forth as we move up and down the column. In fact, there is a little glass tube that comes down from the upper tray and comes within a few centimeters of the surface of this tray below, and that's what is called a downcomer. In industry, they look quite a bit different. This is the top of the distillation column, and so the vapors are coming up. They come up to a condenser. In industry, that condenser is in another vessel off to the side. On this one, this is a laboratory version, and so the condenser coils are actually sitting inside the top section. We've got cold water coming in through here, goes through the tubes and goes out. We get warmish water coming back out. The vapors that condense, they've been cooled, so the vapor gives up its latent heat energy. It goes into a liquid phase. It shrinks 1,600 times in volume, and then it drops or dribbles back down and goes back down the column. If we were taking product off, it would come out through this valve here and go off down to a collection vessel called an accumulator. The fact of the matter is that we run this column at total reflux, so we actually leave this valve closed so that this little magnetic control will switch back and forth, so it's putting some reflux down here, and then when it flips over to put it in as a product out, well, it just overflows and goes down, and we end up, as I say, at 100% reflux. Looking at the trays, this is a cross-section of trays. This is looking from the underside and then from the top side of the same tray. I probably should have had a second one of these, and then you would get a better perspective. But there's a hole here, and that's where that glass tube that I just described goes through, and it connects onto here. So the glass tube is up where the level of my blue mark is. The liquid will overflow down through the glass tube, and the tube will come out through here and then come within centimeters of the next tray's surface. So this needs to be this way. On the next one, the tray needs to be circulated around so that the reflux would be taken from the opposite side. So they go opposing sides back and forth across. Sample taps. This sample tap here samples the vapor phase, and it comes out through here, whereas this sample port here samples the liquid phase, because it's liquid on top of the tray and it's vapor underneath the tray. The liquid comes out through that one, vapor sample comes out through this one. And as I've indicated here, there's a glass tube going down to within centimeters of the lower tray. That's the downcomer on the other side.
On the right-hand side.
Yeah.
And then moving up a tray, you see downcomer on the left-hand side.
Yeah.
And then back on the right-hand side. Oh, you can really see that one.
Okay, that's good. Okay, so we're around the back side of the distillation column right now. It's over here behind me. What I need to do is to look at the water and the steam that are coming in. So back here is a water header, and this water header is open. The valve goes wide open and back a quarter turn, so it doesn't get back seated. This line here goes to our refractometer. We're going to see the refractometer shortly, and so I'm going to open that up to put cooling water to the refractometer. This line here is going to the distillation tower itself, and I need to open him to make sure that we're putting cooling water up at the overheads condenser, and that basically gives us the water that we need, domestic water, going to those two sources. Right behind me here, down low below me, are cans of isopropyl alcohol and normal propyl alcohol, IPA and NPA. And then back in the very back is a mixture. As we mix this up, 4 parts of NPA, which is propanol 1, to 1 part of propanol 2, which is isopropyl alcohol. And that's the mixture that we put into the distillation column itself. Now, if I look around to the column over here, I don't know how well you can see that. There's a support tray in the bottom holding the glass column up, and the liquid level should be sitting right up about there. So I don't know, Ray, whether you can get up on top and look down in there, but there's the actual liquid sitting down inside it. Basically, there's 20 gallons of NPA and 5 gallons of IPA in that distillation column. Samples, we're going to draw a sample out of the bottom here, through here to this point here, which is going to be L9, that's the liquid in the bottoms. Okay. Then further up the column, there's going to be a whole bunch of taps up here, and so going way up to the top up there, we're going to be L1, L2, L3, L4, L5, L6, L7, L8, and the liquid in the bottoms is going to be my L9. So to measure all of the samples of the various trays and figure out what the fractions of the distillate and the bottoms are in each tray as we move up the tower, we're going to use a refractometer. And this refractometer, which has been around for a long time, although I just this morning was on the web and found a brand spanking new one, and it doesn't look any different than this. And I think this guy's probably 50 years old, and yet this morning I find a new one which is almost identical. Anyway, what we're going to do with this is we're actually going to take samples, and we've got a whole bunch of little sample bottles right here. This first bottle is isopropyl alcohol, or 2-propanol. The second bottle is 1-propanol, or normal propyl alcohol. And we're going to actually measure the refractive index of those two, and over to the graph, which is over here. I've got a graph that I plotted out, and the normal propyl alcohol has got a refractive index of 1.3840, and the isopropyl alcohol has got a refractive index of 1.3762, and then all of the other alcohols, when we measure the various samples, we will look to see what the refractive index is. Then on this graph, look from refractive index and then figure out what the percentage of NPA is in the sample. So this is running from 0 to 100% normal propyl alcohol. And of course the balance is going to be the isopropyl alcohol. So this is how we're actually going to be able to figure out what fraction is on each tray. I've got a blank sheet over here that I'm going to fill in all of my samples on, and the two at top and bottom are the IPA is sitting at 0% here, and the NPA is sitting at 100% there. The refractometer requires a very constant temperature. So there's actually a temperature bath sitting here, which is going to control the temperature of water coming off. I'll just move these out of the way. A moment. So water is going to be pumped out of here into the refractometer, and I don't know how easily you can see this, but if I open this up, there's our prism and the actual light source itself in there. There's a light down here which will turn on, I think, yeah, and I don't know whether you're going to be able to get anything in there. Yeah.
I see a little light.
See a little bit of light. There's going to be a scale that I'm going to read. The top one I'm going to actually set up to get to neutral refraction. You know that through a light prism, one end of the light spectrum is the infrared and the other is ultraviolet. And so when I move this knob, this top knob, back and forth, it will actually rotate up into the ultraviolet and down into the infrared. You go back and forth until you find a center line, which is kind of black. Sets you in the right refractive index range, and then what you're going to do is rotate this knob to move the line up and down so that it meets two crosshairs, and at that point then read what the refractive index is. In the meantime, this thing has to be at exactly 25 degrees C. So we're cycling water through the top head, and then it's also going through the bottom main body. There's a thermometer in here, which is, I hope, reading at 25 degrees C. If I put my laser on it, you can't really see with the laser. But anyway, where my fingernail is, it's at 25, and this guy is also at 25 on that bimetal thermometer. So we're going to control the temperature of this. So my bimetal thermometer is right there, and you can see that it's partway between 20 and 30. It's not all that accurate. The mercury thermometer is far more accurate. So what we'll be doing is taking samples, putting them on here, closing the door, bringing another light in, which is right here. Turn it on. I like to go up to sort of a medium-high light, and then I'll be able to see what's happening on the actual prism itself. And so looking in through there, I can't see much yet because I haven't got any sample on. It's kind of showing a gray color. So we'll get back to this guy in a little while, but I'm just going to leave this temperature running constant in here so that it gets stabilized before we actually start to do any tests. All right, so next thing we're going to do after this is we're going to go over and start bringing steam over to the column, and then it takes a long time for it to warm up. Okay, so we're moved over to the other side of the lab, and this is actually on the north side of the lab. And where my laser is pointing, there is a steam line coming up from the tunnel down below. This is coming from our steam plant, and it's going to go through that valve and actually wrap the entire lab. What I'm going to do is put my gloves on before I hurt myself, and then I'm going to open up this steam valve. Slowly, very slowly. This is 140 psi or 965 kilopascal steam in this line right now. We've started up the boiler over on the other side in the educational steam boiler, and the Nebraska boiler is feeding steam over for this lab right now. Now, I'm not going to bother opening this valve wide because the amount of steam that this little tiny distillation column, this little glass still takes is next to nothing. And this still is really very small compared to what we have in industry. The industry ones are much, much larger. And we have another one of these, which we'll probably do another video on over on in the instrumentation lab, which is a cross-flow side tray. This particular still here is bubble caps, but it's only got one bubble cap per tray. The cross-flow side tray has got 630 side holes on every single tray. And so significantly larger, but again, nothing compared to industry standard size. So the amount of steam that we're going to use is minimal. So I'm going to go around the corner here, and I think we're able to just let me slide around. There's another valve in the back. This is a ball valve back here, and you want to be very careful with the ball valve. It's kind of quick opening. I'm going to open it very slowly, and I can hear water going in there right now. So that is condensate that is formed in the line because the lines are cold and the steam is coming in. It condenses, and of course the pipes warm up, and then all this condensate has to go out through traps and either go back to the steam plant or be dumped into the sewer, because basically it's just water. So you can hear I'm just cracking this thing open. And the line actually goes around behind me, and Ray, if you just catch it over here, it goes down this side wall all the way to the far end of the lab. And then on the back wall, Ray, if you shoot back to where my laser is back there, it's going all the way around, and then right back down there, that line at the bottom, that insulated line, that is the steam line that we're charging. The distillation column, of course, is over in here. So it's going to take a minute to warm this line up, so Ray, you can turn the camera on. Okay, so we're now at the far end of the lab. Here's our steam line coming along the back. And in fact, you can see right here where the line goes down, it's kind of a dead end. It's like what we call a drip leg. So the condensate that's forming will collect in here and then goes through a strainer, and then this is a thermostatic trap, which is then going to feed back to the lower line down there, that guy down there, which is on this line here, and that's the condensate that's going all the way back into the tunnel that runs between the boiler house and here, and then that condensate actually goes back into the steam plant and is reused and made into new steam. So now, the steam supply comes in on this valve here, and we got a gauge in here. We're going to run this thing at 160 kilopascals. I'm going to move these two buckets out of the way. So I'm going to crack this guy open. And I'm going to open up this drain. There's a drain here. You can hear it draining into the sewer. See the steam coming out. So I know now that I've got rid of my condensate. I'm going to close this valve back off. And I'm going to open this valve slightly. This guy here. Just going to put a little tiny bit of water. The condensate came out, and now I can see steam coming out of there. So that's good. I'm going to shut him off. And I'm going to, you can see my pressures come up to my 160. And I'm going to slowly open the valve. Now, if we need to raise or lower this pressure, this spring right here, there's an adjuster and there's a spring underneath there so that the regulator will set the pressure. And this wrench stays here hanging on this, because if you need to adjust that guy, you're going to take this off of here. Gloves don't help. And then you would either lower the pressure. You can see I've turned it counterclockwise, and you look now, the pressure's dropped down to about 153, 154. I'm going to bring it back up to, I hope, 160. Now if it gets too high, there is a safety valve right here which will relieve. And I'm just going to pop it so you get the idea. Okay, so then the steam is going to come along here, through here, and right now, if you look, you can see a shimmering effect taking place inside that reboiler. And you can see the bubbling that's happening up in there, and it's going up, and the level that's in here is rising. And the reason the level is rising is that the NPA IPA mixture is being heated up and it's expanding. The steam is coming in, actually Ray, if you got your, the steam is coming in on that line there. Okay, so the steam is coming in on this line, and you can see it going right into the glass tubes themselves. And if you back out a little bit, Ray, if you look down in here, and I'm going to take my laser away for a minute, but you can see how the liquid is actually swirling around inside those tubes, and the condensate's coming out right down here. Now, Raymond, I don't know whether you can get it, but if you, from the angle I'm at, I can actually see this stuff. So that's okay. Come on back here, or whatever.
Right there.
So you can see the condensate coming out, which is kind of cool. And now the condensate, and the condensate comes down through this trap down here on the end of this hose. Follow the hose down. And comes into this blue trap that's in here, which is a bucket, an inverted bucket trap. And then the condensate will go out and simply drops into the sewer. And I can actually see, I don't know whether you can see it with my laser on it, but through that hole right there, I can see the water going down the sewer. Okay, so you can look up a little bit again, and you'll see that the level is starting to climb there. And shortly, it's actually going to overflow into here and then start warming this bottom section up. And I don't know with your camera, if you're looking down, you can see the liquid in there right now. But not much is happening. It's staying pretty stationary. But once we start boiling, and you can see it's boiling more rapidly now. Look at all the bubbles that are in there. And the level's starting to get close to where it's going to spill over. And then what it's going to do is it's going to surge as it goes over. It's going to, you'll see it kind of surging in waves. Almost to the point where there's going to be a little bit of liquid starting. There it is. It's just starting to spill right now. I can see it. Just spilling into the bottoms. Now obviously the stuff that's inside here is cold. This is cold in here, but now if you look at the bottom here where the glass is, where the outlet is, I can actually see this shimmering taking place in there. Nothing right now, but it did a moment ago. As that liquid starts to go down. And this is what is called a thermal siphon. So it's actually, because of the heat that's going on to it, the liquid is lowering density, it will rise, and then it begins to recirculate naturally. And distillation columns typically operate on thermal siphons. We don't have pumps down on the bottom. And this is going to get going pretty well in a few minutes. And eventually what will happen is the liquid is actually going to start, you'll see it coming up the side of the glass, and then it'll start heading up the trays. Okay, that should be good enough for now.
That's really cool.
Yeah.
Nice.
Okay, so you can see the thermal siphon taking place, and it's slowly heating that up. And actually I can see a bit more shimmering in the glass down there. It's not really obvious yet, but it will get really obvious. You can see shimmering in the bottom of here. So that's the hot liquid starting to go down. And I can see a little tiny bit of shimmering periodically happening in there, but it'll get more and more. There, a little slug of warm stuff went down there. We're going to take our liquid bottom sample out of here. When we do that, we're actually, right now it's got a lot of liquid trapped in it. We don't know what it is. So once we get running, we're going to drain that out of there and get a decent sample of it. The trays that are in here, all the way up and down the column, are what I call bubble caps. So Ray, if I can get you to get a picture of this guy. This is a sample of a bubble cap. It's only one bubble cap on the whole tray. Normally there's hundreds of the things. What happens with this is that the vapor comes up from the tray below and comes up into here, and in there, and I don't know whether my laser is going to mess this up or not, but you can see that there's the top of the cap, there's a gap between the chimney, which is the part going up there, and the top of the cap. So the vapor comes up, goes across up the chimney, goes across over, and then drops down and comes out these holes. There's liquid on the tray. So what we're going to have is we're going to have a liquid level, which is actually set by a glass tube that goes through this hole here. So there's a hole in there, and it goes through that hole and goes down to here. That'll be reflux going back from this tray to the tray below. The liquid level makes sure that the vapor discharge ports are covered so that vapor coming from the tray below cannot get to the tray above. It actually has to get condensed, and then it boils on this tray, and this tray's vapor goes to the next tray. It condenses, then its vapor goes to the next tray. And as you're going up, the temperature is going to decrease, 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 because you're actually changing kinetic energy, that's the velocity energy, into potential energy on the trays. And so each tray comes in as kinetic, gets converted to potential energy on the tray, then that potential energy heats up the liquid, and now this liquid vapor goes up, and you've got kinetic energy going up. You can't create or destroy energy, but gravity would like to bring all this stuff down. You're having to use some energy to overcome gravity, and so therefore it's moving in an upward direction. So something has to change, and what changes is the temperature. The potential energy on trays going further up the column becomes less and less and less. Only the most volatile component, which in this case is the isopropyl alcohol, will make its way to the top. The normal propyl alcohol will stay at the bottom, and there'll be fractions of it all the way up and down the column. That's how a distillation column works. At any rate, with these also, we've got some little sample valves on the sides, and you can see them. There's one there, one there, one there on each tray. And what we're going to do is we're going to take those samples, and they're on the other side of the column. There was some tubes on there, and we'll be drawing samples out. So let's take a look at the box. The way this column is set up, you can see a surging happening there right now. See it surge? And the level dropped way down, and then all of a sudden it took off again. You see it surge down and surge up. And that's caused somewhat by the trap that's opening and closing. Once we get fully running, this thing is going to stop surging. The liquid that was inside the bottoms was cold, and so that cold liquid kind of slowed down the boiling when it came in here. Once it gets going again, it'll surge over. And eventually, when everything gets really hot and it starts to boil, which it isn't boiling in the bottoms yet, you'll actually see a film of liquid start to climb the side of the column, and then it'll go up into the trays up above. And it takes about an hour to get this thing to get fully settled out. Okay, that's probably good enough for now. Okay, we're up at the top of the distillation column, and that water that I turned on earlier, the cold water, is actually coming in here. I'm going to take my glove off so that I can feel it, but it is cold, and it's cold coming out here because nothing much is happening. The vapor or the liquid will come in and it goes up the coils and goes out. The vapor, once it makes its way up here, which is going to take a little while, well, you'll actually see it. And it's kind of neat when it's running. You can put your hand on here and, gee, that's warm. And you know, it's cold there and it's hot there. And that's exactly where the end of the vapor got to. On this column, if you forgot, which we did once, to actually put the cooling water on, the pressure will build up in here. So here's our safety valve. It's nothing more than a plastic, beaker just sitting on top of there. But this thing is supposed to be running at atmospheric pressure. No pressure in there. So again, this is a little safety valve, and if we forget to put the water on, it gets a little smelly in here. Smells like a dentist's office, which is what it is when you go to the dentist's office and you have that funny smell, or a doctor's office. It's isopropyl alcohol. That's what it is. Same stuff you use for all the hand wipes and everything for COVID. And so anyway, the liquid is going to form when it comes up onto here, and then it's going to drop back down and go into the bottom of the column. Okay, I went downstairs and I started up the reflex ratio control. Now, this distillation column is a laboratory, educational demonstration unit. It's not really a practical still. And the way they do reflex control, if you remember from your notes when you went through this, reflux is pure distillate that you put back in on the top tray, and then that floods the top tray. So only the most volatile component that makes its way to the top tray is going to boil off with the reflux. And the liquid that's on that tray will go down and reflux the next tray, and so on all the way down the column. So the reflux that's been added is added using this device here, and this is a laboratory device. It's got a little magnet, and what happens is that the magnetism turns on and off. It's an electromagnet in here, and it repels this little bucket, moves it back and forth. So I'll wait until down. Now what it would be doing is it would be pouring liquid down through here and down the tower. Now it's attracting, so it's pouring it into here, and that would be going out this way. This valve is closed right now, and would be coming off as your distillate. So this is L0. This is the distillate, as close to IPA as you can get, that's going to come off the top of the tower. And so he's spending a 50% time this way and that way, and I've just gone and set it. All it is a timer down there that times how long am I going to reflux, how long am I going to take sample out, and it's just going back and forth. You would never ever see one of these in industry unless somebody's doing some research work making small amounts of something or other, and this would be a perfect column for that. So I can now see, if I look into this tray here, I see a little bit of bubbling just starting to happen. So the stuff is starting to climb up the tower, and it's getting warm. And later on, you won't touch this because it's going to be boiling pretty good. And I don't know whether, Ray, you can get a shot down there. And take a shot straight down and look into the bottoms, and you can see that now is violently coming out of the reboiler and going into the bottom part of the tower, and then it's boiling and coming up through all of these trays. Now we're just starting to get some reflux happening. You see these come back up here. You see these little tiny drips where my laser is there. You can see drips of reflux beginning to come. And right now it's just, actually, I don't know whether you can catch this, but I can see the film climbing the tower.
Oh yeah.
Isn't that cool?
Oh, that's sweet.
So it's the cold glass that's creating the reflux right now. We're not up to the top yet. Well, we're getting there. It's just starting to go up into here now. And the next step is to get to here.
So cool.
It's right in the middle right now. I could see it looking over the other side. You'll see a film coming up here in a second.
A little bit of movement.
There she goes. And now if you come back down the column, you can actually see how that reflux ratio is working. Right now it's taking product, now it's going to reflux. Now it's going back to product. Now, it overflows all the time because the product valve down here is closed right now. And this particular column doesn't work under normal full control. Trying to take product out, trying to take bottoms out, put feed in at about the third or fourth tray from the bottom. They never were able to get this thing working, but it runs on what we call 100% or total reflux. And for demonstration purposes, to allow people to see what's going on, it's rather unique. You can see now on this tray, look at how violently that tray is boiling now. It's boiling quite well. And then later we'll get down below. We'll let it stabilize quite a bit more yet. But we'll get down below and then we'll look to see what the reflux looks like coming back down the reflux tubes. So let's go up, Ray, and I can see now the liquid is starting to form. You can see it forming all the way around there. And in fact, I'm going to put my fingers on it. That's hot right there, and that's stone cold right there. And you can see the vapor line. And as I say, we're going to let this thing run for about another half hour. And then we'll come back to the video and actually take a look at what's going on. Okay, so that's good for now. Okay, so if you look where my laser is right now, you can see a glass tube in there, and I'll take the laser out for a minute. And you might be able to see liquid coming down that tube. So that tube actually protrudes up into the next tray a little bit. And so the reflux, or the overflow from that tray comes down onto this tube and refluxes this tray. This guy has a tube sticking in the top and coming out down here, and that one goes down onto this next tray. And there's another tube, it's not going to be easy to see, but there's another tube over the other side here, and it comes down here, and that's the reflux coming down onto this tray. Now this one, if I can get my laser in close enough, it's really hard to see. But there's another tube. I don't know whether, Ray, can you catch that tube down there? The tube coming down from the tray above? Maybe not.
It's kind of hard to see.
Yeah, there's so much boiling going on in there.
I see that too.
Okay, let me see if I can. Okay, can you come up a little higher?
Yep.
What I want to try and do is see if you can get down into that one.
Okay. Turn the camera a bit.
So about where my laser is pointing is where the actual tube extends to. So it comes up there. So you have to get up to the liquid for it to overflow and then go down the tube. So the reflux is going down that tube onto the tray below. And similarly, the tube over on this side is coming from the tray that's up above that. And so on all the way up the tower. Okay, now we're going to head back upstairs. So here we are back up to the top. And this is what is called an overhead condenser. Now in the real world, vapor would have come out of here and then go over to a horizontal condenser where it would condense and then come back into the accumulator vessel. And from there we would pipe some reflux back in from the accumulator, which is our pure distillate, into the top tray of the distillation tower and then do it artificially. But you can see this guy is hot, 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 cold, hot, cold. Right there's the line. So the vapors got up that high in here. This is all stone cold up here. The water coming in here is cold. Water coming out of here is not much different because we've got so much capacity in here. Now, the reflux, again, as we said earlier, will go down when this guy flips over that way. So what I'm going to do next is I'm actually going to turn this is our LO sample point, and I'm going to turn this valve on, and what it's going to do is drain a bunch of that stuff. And now you can see that it's going this way, and then it refluxes that way. And then it's going to flip this way and go back down through here, and you can actually see the liquid flowing through this line. And then it's flowing, you can see it really flowing down there. Now I don't want to lose too much liquid, so I'm going to shut this guy back off. What I was doing is getting old sample out of there, so I've got fresh sample in for the way we are now. And this should have collected down in the bottom, so I'm going to go down to the very bottom there and drain that away. And see the reflux. You can see this thing boiling like mad there.
You can really see the reflux there.
Yeah. Okay, and these are our sample points. We're going to come back in a few minutes and take. So this was L0 up here. This line that I opened up, it's marked on it L0. And then this one is going to be L1, and they're labeled L1, L2, L3, L4. These valves, I'm not going to do this because it would leak, but when you rotate them so they're pointing out this way 90 degrees, they'll open up and you can get a sample out of it and put it into the little bottles. And we'll do one or two so you can see, and then we'll take them all. And then they're closed off when they're back in this position here. Okay, we're going to go downstairs. Okay, so the sample that I let come out of LO and go all the way down is down at the bottom here. And I'm going to take a bottle that's back here. It's marked waste alcohol. So when we're finished with all these bottles, we can pour all the waste alcohol back in here. And then all we do is pour it into the top of the column. Where we had that cup on there to act as a safety valve, we just pour it back down, and so we basically don't lose any of it. So now I'm going to go over and I'm going to drain all that LO into here. So I've got my bucket with me. You'll notice I got my gloves on because this stuff could be warm. In fact, where my finger's pointing right now, there's where all that LO that I dumped from the top, it all collected down in here. So we're going to drain that off, all of it, until it doesn't drain anymore. It's almost empty. Maybe not. I can see the level coming down. It's still draining out there. Now we're down to drips. Okay, so I'm going to close that guy off, and then we'll go back around the front so we can shut that off. Ready. Okay, so again, my LO is going to come from here. I just drained the bottoms out of that vessel, so now I'm going to open this guy up. You can see that I've got liquid going in there, and we'll let it run for a few moments. You can see it actually dribbling down inside there. There's actually another condenser down there to cool it down. That's probably enough. I'm going to close this guy back off. Then we're going to go get one of our sample bottles, and we're going to go get some sample of L0. Then we'll work from the bottom of the column all the way up to, we'll come back to tray 1, and we'll get L1, L2, L3, L4, L5, L6, 7, and 8. And then 9 we're going to take out from the bottom. Okay? Okay, so we're going to take L1. I'm going to take the eyedropper out. I'm going up here to tap L1. I'm going to stick this tube into the bottle down to the bottom, and I'm going to open the L1 tap, and there's liquid coming out now. You can see the liquid level rising in the bottle. I'll get about a half a bottle, or a third be enough. I'll go half. Okay, I'm going to shut this valve off. I'm going to let the liquid get out of here so I don't end up with it dribbling all over the place. And there is my L1 sample. Thank you. Now, this is liquid 3. Now we're going to take L3 out. And it's filling with liquid again quite quickly. That's our liquid 3 sample. Just kind of dribbling it all out of there to make sure that we don't end up with it all over the floor. So this is L3. And I've got L5. L5 is going to be down a little bit lower. That's going to be this guy here. So I'm going to again take a sample. Bottle's filling. Ooh, quickly. Unfortunately, I think I got out too soon. Okay, I'm going to come down a bit. And this should be my L7. Oops. I don't have an L7. You want to go look for an L7? Okay, we're going to take an L7. And I'm going to put that tube in there. Now, open the valve. Okay, we're going to go over the other side. Okay, we're going to do L2 next, which is this guy here. Not getting very much. Real slow. The higher we seem to get on the column, the less level we've got on these trays. So L1 is not looking like it's giving me very much, or L2 is not giving me much, but I am getting some. You. L4. L4 is next. Take that one from there. I'm getting a fair amount right off the bat. Four. L6 is the next one. L6 and L8. This is my L8 bottle. Bottles. Got it. I'm going to take a V9 from the vapor. So this is actually going to be looking at the vapor right here. And later we're going to take an L9. So we're looking at the vapor side of the bottoms, and we're going to look at the liquid side of the bottoms, which will kind of show you the difference in separation. So I'm going to go in here. Oops. Change hands. Stuff is hot, so the vapor may come quite a bit slower. You can see if you look into the glass, I don't know how well you can see it, but it's actually bubbling in there. And it's getting warm. But I got to get enough sample that I can take it out with the eyedropper. Oops, sorry. I did it again. Now, Murray, this is really hot. Okay, so our bottoms are actually coming down here and going out through our reboiler. So we're actually going to take a sample through here, all the way through to here. So this is all kind of dead liquid right now. And we've got to basically run this thing long enough that we get some warm liquid through here. Now it's not going to be hot, like the bottoms here is very hot, but this is a cooling jacket, or not jacket, but tubes inside. So it's going to cool that down, but it will be warm. It'll be hot here and warm here. So what I'm going to do is I'm going to take and open up this bottle. And I'm going to let this liquid 9 go into there. So if I open that up, you can actually see, once I get my hands out of the way, a liquid stream. Okay, so you can see that liquid stream going in there. And I'm going to drain it so that I just about fill this bottle up. So I make sure that I've exchanged everything out of here. So take my gloves off and feel this line. That's getting warm now. It's got warm to here. It's cold back here. So I still got stagnant sample sitting in here. And I want to get warm sample coming out down here and out down here. Okay, so we're draining into a 4-liter jug, and I've got about 3 liters in there now. So I'm going to shut this off, pull a little sample line out, and then we've got our, you can take the plug out there. We've got our L9 right here. So that's going to give me my bottoms. Thank you. Now, lid on here so I don't spill this. Okay?
Yep, good.
So our L0 sample is taken from here, and there's still some in there from the last time we ran. So I'm going to take and drain that out of there. It's a little tiny bit, not much. That's a fair amount. You can see it going down there. Going down there, right where my fingernail is. There it is, going down, 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 down. And we are almost empty. There it is. Drip, 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 done. Okay, what we need to do is we need to go up to the top of the distillation column. So to make sure that we've got a fresh sample of the pure distillate, the L0, we drained this down, but we still got a little bit sitting in a leg upstairs. So we're going to go up to the top, open that valve up, let it run a little bit so it's feeding down to here, close the valve back off so we know we got fresh sample in there. And then we'll come back downstairs, drain this off into that jug so we can reclaim it. And then we'll close it off, then we'll go back upstairs and open up the L0 line, the distillate line again, to get a nice fresh sample in here. And then we'll close it off, then we'll come down and take our sample. Okay, we're going to get our L0 sample out of here. So I'm going to open this valve up and let that all drain out of there. So it drain nice and fresh out. I'm going to close this valve off so I get a new sample. I'm going to go downstairs, drain it, and then we'll put another charge in there and then we'll measure it. Okay. All right, so now we're going to take our L0, which we've dropped it down from the top where it came through. We opened the valve and we've got that much sitting in there. Last little bits are dripping in here. I'm going to put my bottle in here and get a fresh sample of L0. That's good. Now, I think what I'll do is I'm going to drain that off just so we don't end up with a leaking or anything. Just leave it on. So we're draining the balance of the L0 out because we're basically finished with the distillation operation. So I just don't want to leave anything left in this section line. You see the level coming down here. Good. Okay. Okay, so this bottom's cooler is cooling it down. It's quite hot there, and it was sort of warm coming out of here. We've drained a fair amount out. So we're going to take this as L9 now. That's good. Okay, so back to my little sample trays. These are little eyedropper bottles, and we're going to fill them up. This is going to be the LO, which is right up on the top. We're going to go up there in a few minutes to look at that. Again, my NPA and IPA at the two ends. And then starting with the top tray, L1, and I've got some liquid in here because I ran it a couple of weeks ago, but there's nothing in L2. L3 has got something, nothing in L4. L5 has got something. L6 is empty. L7 is empty. L8 has got a little bit in it. And then L9 is going to be that stuff down at the bottoms. So today we're going to go through and we're going to get all of them, and then we'll do an analysis on them later. But the column is, as I say, going to take us an hour to really come up and get itself straightened out. So we're going to shut this off right now, and I'm going to go upstairs and we'll take a look at the top end. Okay, so I've reread it, and I've actually got L3 at 1.3792. The IPA is 1.3762, and the NPA is 1.3840. So I'm going to pull that sample out. That's a 3, and I think I had I got an 8 here. So I'm going to take that light out. Move this guy back. Wipe. Clean. again. Those hoses kind of cause it to spring. So I said this one is L8. So L8. I must have bumped this. My horizon kind of disappeared. My black line back. Now I gotta shift it up. So let's have a look and see what this looks like. So IPA was 1.3762, L3 was 1.3792, so it had increased. Now we're at 1.3824 at L8, but we're not up up as high as the NPA is when it's at 1.3840. So you can see proportionally it's moving for us. What have I got? What else have I got? Here's an L5. We didn't do an L5. Latch. Right. Now, my line's above it. And now at 1.3803. I said that was L5. L5 1.3803. So again, 1.3762 up to 1.3792 up to 1.3803, then 1.3824, then 1.3840. So you can see that we've got different fractions on every single tray. This is what the refractometer is being used to tell us. Okay, that's enough. You can see just how well it's boiling. As a matter of fact, it's almost flooded in there. And then as we get up to about the mid zone, it begins to settle back up. So these lower trays are really boiling violently. We're going to start a shutdown sequence. And to shut it down, it's just a matter of turning off the steam and letting it vent out. So we'll go over to the steam valves. Okay, so we'll head over there. We're going to We're going to isolate the main valve first and try and let the distillation column lead the steam off the lines here. Okay, and we'll just let the distillation column go for a while and bring the pressure right down. Okay, that's good. Okay, we've got a bunch of sample bottles here, and we've labeled them all. This is marked L1, 2, 3, 4, 5, 6, 7, 8, 9. And we also got a vapor 9 here that I'm going to take as well. And then I've got my raw samples of monopropyl alcohol, or 1-propanol, and isopropyl alcohol, IPA, which is 2-propanol. And we're going to go over here to the refractometer. We're actually going to take samples of with the refractometer and measure it. Now, the trick with the refractometer is to make absolutely sure that it is clean. Now, before we started it up, we put some cooling water on. You saw that at the beginning of the video. We turned on this temperature bath. It is controlling the temperature of this water to exactly 25 degrees C. And there's actually a dial or a thermometer sitting in here, a mercury thermometer, which is measuring that temperature, and it says right now it's at 25 degrees C. I'm going to turn some lights on here. First of all, I got to get a sample in. So I'm going to take and pull that back, and I'm going to grab the bottle of cleaning fluid and spray it on there, and then use a Kim wipe or two to actually clean this surface area. You want to clean it very, very well. And then what we're going to do is we're going to take a sample of the NPA, normal propyl alcohol, which is in the bottom, and I'm going to put that on this window. And you kind of got to drop it on there and move it around until sort of make sure that you covered the whole area of the window. So I'll drop the window back down, make sure it latches. I'm going to turn on my light. I tend to like to go to about the medium height rather than the low. And I adjust the light at the back so it's just about touching the window. Now, there's two windows here. The first one is looking at the horizon, the actual refraction. And unfortunately it doesn't show up on the video, so I'm going to try and put some picture clips in here that I took on my camera, and I was able to show how the spectrum breaks out. But if you remember the visible light spectrum, on one end of it you've got infrared, on the other end of it you've got ultraviolet. And so what I'm going to do now is I'm going to adjust this dial to actually move into the ultraviolet, and then move into the infrared, and then come back to a black line right between the two, which is where they all come together. So putting my eye on here to focus. First of all, the focus isn't quite right. You got to watch it. This is a knurled handle on here, and you think you can twist it and adjust it, but you can't. It just slides up and down. So you get the crosshairs still there, absolutely clear. And I'm adjusting right now for blue, and adjusting the other way to red. And come back and find that sweet line that it's just a black line across there. Now, we can move the black line up or down with this refractive index dial. So what you do is you move the black line up or down till it covers the crosshairs. So there's crosshairs down in there, and I've got to line that right across the center of the crosshairs. So I'm adjusting it right now. You get it? And then I've got to read the refractive index, and I need a piece of paper. You want to get me one of those? Okay, so while we're waiting for the distillation column to stabilize so that we get good representative samples, what I'm going to do is I'm going to set up the refractometer. So the refractometer, as I said, has got 2 viewports on it, and you've got to watch these, and I've actually written up instruction notes on how to use it because I never did find any. But you can slide this focus up and down. It doesn't turn. Even though it's got knurls on here, there's no threads, it doesn't turn. So you basically got to set it up for your eyes, and of course me with my glasses, I got to take them off to look at it. And so right now I've pretty well got this guy lined right up, and you can see a refractive index scale down this sight port. And I don't think that's going to pick up on the camera, but go ahead and give it a shot. I don't know whether you can get into there. You really got to get the lens right on that thing and come back a little bit. Yeah, very hard to see. I'll try and get still photos of it. Okay, so then up on the second one up here, what we're going to do is I'm going to, for reference purposes, calibrate the IPA and the NPA. So I've got some lens cleaner, glass cleaner here, but I'm just going to spray on the prism on there, and then use a Kim wipe and wipe that nice and clean. You've got to make sure these surfaces are perfectly clean, and you won't get anything if you don't, but be very careful because these are very fragile. Now I'm going to start with the NPA, normal propyl alcohol. And what I do is I take a sample of that and I put it on the glass and try and smear it around so that it covers it completely. Okay, now I'm going to take this guy and close him onto there and latch it. Oops. That's latched. Then I've got to bring the light source over. And you can go low. I typically set it to medium. And we're going to adjust the light source. I don't know how well you can see it back here, but I'm going to almost touch the glass and put it about the center. So now, I'm going to move this until I get the ultraviolet side. I don't know, Ray, whether you can actually get a picture of that. Try and get down through that lens and see if you can see the picture of the ultraviolet.
Top one.
And you can see a bit of blue in there. Okay, back out, and I'm going to go on the infrared side. Okay. Does that look reddish?
Yep, red.
Okay, back out again, and I'm going to adjust it back so that I bring the red and the blue together and form a black line.
I see some blue and red.
Hmm?
I see some blue and red, but no black line.
Okay, the black line is right between the two of them.
Ah, okay.
Okay. Then the next thing I got to do is I got to take that black line now and raise it up to where there's a pair of crosshairs in there. And I line my line up. Hit smack on that across the crosshairs. And then I read to see what the refractive index is. And the refractive index is reading 1 point, and I have my piece of paper here. Refractive index is reading 1.3840, which I think I already wrote in here because I knew from doing it previously. I wrote it down on this one, I guess, 1.3840. 1.3840. And I don't know whether you're going to be able to, yeah, you can see that. I don't know whether you're going to be able to get this on there or not. Not really, eh?
I see a little light.
Yeah, well, no, you can't. There's lines and graticules in there. Okay, so that gave me my normal propyl alcohol. So now I'm going to back my light source away. I'm going to back this guy off. I'm going to wipe the lens clear of the normal propyl alcohol that I put on. Then I'm going to spray it a little tiny, just a little drop. Wipe that clear again. You could use mild dish soap and water if you wanted to wash these things. Just want to be careful you don't get scratched. All right, so then I want to get my IPA sample. That on here. Latch it in place. Put my light back on. Now what's happened? Oops. Something's not right there. Oh, latching. That's better. You got to make sure this is latched down. If it doesn't, you'll get all gray color. You lose your lines again. So my black line is actually shifted way up. I don't know whether you can try that upper one and see if you can catch that. Yeah, I think so.
Oh, kind of see it, yeah.
But it's above the crosshairs. So now I'm going to take, and with the refractive index line adjustment, I'm going to back this guy down so my black line goes right through the crosshairs. And now my refractive index is changed to 1.3762. And I think that's what I recorded before, was it? 1.3762. 1.3762. So you can see we're down 4th decimal place in here. You've got him, and the last one here, there's no line there. You actually have to look at a graticule and then kind of between the two graticules estimate what it is. And each time I do it, it comes out pretty well the same, so I think I'm doing it right. Okay, so then, not that we've got a fresh sample, but I'm going to pull this guy out of here, and I'm going to grab one of the samples I had from my previous test, just so that you can see how they actually shift. Again, clean. Cleanliness is next to godliness. I really got messed up with this thing when I was first trying to get it running, because it had been sitting here for years and nobody looked at it. And for love nor money, I could not get this thing to work. And then finally I thought, I wonder if that glass is clean or not. So I got some glass cleaner, I cleaned it, bang, just like magic, it all worked. Okay, so now I'm going to grab maybe a sample from, I had a sample at L3. Okay, let's see what, this is from a previous run that we did. So I'm going to put that on. And put that down again. Make sure it latches. And the light back. Now my line is shifted down, but nowhere near as much as it was before. I'm going to bring it back up. Okay. And I'm now sitting at 1.3792, and I said that was L3. L3, 1.3972. So you can see that the IPA was at 1.3762 This sample at L3 was at 1.3972. Okay, so it's increased a bit, and so Marie is right now going through and using a refractometer. She is taking each one of these samples and then recording them, and then what we'll do is we'll plot those out on the graph and see from the graph, maybe tomorrow, what percentages we actually have. Okay, so she's checking the upper glass to look for where the line is moving, and then adjusts the refractive index knob, the lower of the two knobs, until she gets the line to go through the crosshairs, and then once it's through there, she reads off what the value is to the 4th decimal, please. Thank you.
Go up here. Okay, good.
Okay, so we've gone and we've recorded the numbers. We had our original IPA and our original NPA, and then we took our L0 from the sample from the top, L1 on the first tray, 2, 3, 4, all the way to 9. And you saw me take the 9 at the bottom. And you can see how these numbers are moving. 762 to 780 to 792 to 798 to 801 to 816, and so on and so on. So then what we did was that we took the graph that we had made, and don't worry about these little dots in here, this is from my leftover one, but I have the number for pure pure IPA down here, 0% NPA, and for pure NPA, which means 0% IPA, up here. Drew a straight line because refractive index is a straight line, and then from there we taken and looked at what is the refractive index. So for example, this one here at the LO at 1.3780, 1.3780 is right there. That's nice, that landed right on. That brings me over to here. If I look at, this is 20, 22, 24, 26, 28, 30. So I'm sitting right just about in the middle between those two, so it's pretty darn close to 23%, which is exactly what we wrote in here. And then we went to the next one. We got 39, 51, and this is at the top of the towers where the MPA, so there's going to be next to very little NPA up there, only 23% MPA, which now means that that's running at 77% IPA. Then we find a 50% mixture right about tray 3, which sort of makes sense. And we'll look at the McCabe-Thiele theoretical plate calculation a little bit later. I've got to pull another drawing up to look at that. Anyway, moving all the way down to the bottom of the tower, this was down at L9. This was the liquid we took out of the reboiler and cooled a little bit, and it was running at 89% normal propyl alcohol, therefore 11% IPA, isopropyl alcohol. Okay, so that's how we get the numbers. It's good. Because what I want to do is I want to use up whatever steam is in the line rather than leaving high pressure steam in the line, so that the distillation column is going to consume the steam that's in the line. Okay, so we're going to sit over here at the steam regulator and wait until we see the steam pressure starting to drop, which means that it may take quite a while. And if you heard that little click in the background, that was the thermostatic trap right there that opened up a little tiny bit to let any condensate out. But the pressure that we're looking at is only 160 kilopascals, and the steam coming over here is coming in at 965. So it's on the other side of the regulator there, it was at 965. Now I've isolated the steam valve back at the header, so it should start consuming all the steam that's in here until finally this pressure starts to drop. And once this pressure begins to drop, then I know I've pretty well got the line empty. I can isolate that valve, and I'll open up the drain valve there. Okay.
Yeah, it's boiling.
Okay, so now just keep it on there, and I'm going to shut off the steam.
Yep.
And you should see that reboiler slow right down and stop. And then all of the liquids that are on the trays up above will start to work their way down. On a cross-flow side tray, they will literally collapse, and everything will come into the bottom. On this one, it takes quite a while. The bubble cap is keeps the liquid on the trays. As you can see now, there's nothing spilling out from the reboiler overflow, and you can see the liquid dribbling down the inside of the bottom section. Okay, that's good. Okay, so we shut the steam off, and you saw everything collapsing in the column. Because it's hot and there's vapor in there, we're going to leave the cooling water up to the overheads condenser, and it also actually comes down into this bottom cooler as well. We're going to leave those guys on for a few hours just to cool everything down, so we don't end up with vapors in the lab here. Other than that, we're done. So we'll probably have a little more discussion when I get the final results all plotted out, and then we'll be the end of this video.